So today's lesson is called Simplifying Radicals. Here's a few things I found when I was researching radicals. That first cartoon says, "Welcome to Homework Helpline. For help with science, press 2. For help with math, press the square root of 9. Ha ha ha. If they need help with math, they probably don't know what the square root of 9 is. Anyways, the next one says, speed limit, square root of 677, heavily patrolled. What is the square root of 677? So the speed limit's about 26 in the school zone. And then, yeah, look at that desk. I so need that desk in my house. It is a square root desk. Oh my gosh. See, in that side right there, you put like magazines and stuff. You can store stuff there. And then, how cool is that? Why do I not own it? Okay, so square roots. Let's talk about them. Let's do some anatomy first. That sign above the 16, you know that as either a square root or as a radical sign, because we know that they're not all square roots. Sometimes they're cube roots, sometimes they're fourth roots. So if there's no number there, there's always a 2 understood. Kind of like a 1 is always understood in front of x, there's always a 1. Well, in a square root, there's always a 2 understood. If someone wants it to be a cube root instead, they would put a little 3 there. But if they don't put any number at all, you assume that it's a square root and not a different one. So that's a radical sign. Does anyone know what the number under the radical sign is called? Not the base. It also starts with an R. We've got the radical, and we've got the, there you go, Karthik, radicand. Rishi, you almost had it, you forgot the D. So if you ever hear me refer to the radicand, it is the number inside the radical. Okay? It's a number. Yes, it is a number. So that symbol means the square root of 16. In other words, you're coming up with what number can you square to get 16. So 16 is a perfect square. So the square root of 16 is 4. Okay. Square root of 16 is 4 because 4 squared is 16. It is very useful to know your perfect squares, and I bet you already know a lot of these from 1 to 12. I bet you know these perfect squares, but spending some time at home with these would be greatly beneficial for this unit. Quizzing yourself, what's 5 squared? What's the square root of 64? What's 11 squared? What's the square root of 36? Going back and forth between those is going to help you solve problems quicker, okay? Now, some of you might be thinking, Miss Tanton, you drilled us and drilled us and drilled us, and you counted it wrong on the test. If we did this, and then we put that our answer was 4, I counted it half wrong. Why did I do that? Because it's plus or minus 4. Very good. So I just got done telling you that the square root of 16 is plus or minus 4, yet here, I didn't put plus or minus on any of these. So I just want to go over what the difference is, okay? If you are solving for x and you're in an equation, x squared equals 16, then x is, I skipped a step here, x is plus or minus the square root of 16. Because when you square root both sides, when you square root an x squared, it creates 2 answers. Now, if I just asked you, what is the square root of 16? The answer is just 4. Because it's not plus or minus the square root of 16. It's just the square root of 16, which is 4. So I hope you understand the difference. If you're solving for x, and you have x squared equals a number, then x is going to have 2 answers. If I just come up to you and say, what's the square root of 25? The answer is plain old 5, not the negative, okay? Okay. So, square root some perfect squares, super easy, right? Square root of 49 is 7. Here, let me tell you some ways that I see students mess this up. I see this actually quite a bit. Someone will say, I'll ask them what's the square root of 49, and their answer, they will put 7 squared. And that is not okay. So be so careful. If you put 7 squared, you don't really understand what a square root is, okay? The square root of 49 is simply 7. Don't ever, ever, ever add a squared to it. Yes, 7 squared is 49. But But what's the square root of 49? It is 7. So be very careful, okay? Okay, so sometimes, a lot of times, the radicand is not a perfect square. We know what to do when it's a perfect square. That's easy. So now we're going to talk about what to do when it's not a perfect square. And you probably learned all different ways to do this. So I'm going to teach you one way, but if you like the way a different teacher taught you and you want to keep doing it that way, that will work too. Okay? So I'm going to teach you the factor tree way. Has anyone ever done a factor tree with simplifying radicals? Maybe? No? Let me give you an analogy really quick to simplifying radicals. It's just like simplifying a fraction. If I give you this fraction, and I say, and I say to simplify it, I am expecting you to write 1/4. I'm not expecting you to write the decimal version, 0.25. Does that make sense? Kind of back to that mad minute. I didn't want the decimals, I wanted the simplified form of the square root. So if I asked you to simplify this, you would say that the answer is 1/4. If I asked you to simplify this, would you go to your calculator and give me the decimal? No. You would say 3/7 simplified. Well, Ms. Stanton, that's just 3/7 because you can't simplify that. It's already in its simplest form. We would not go to our calculator and give a decimal if I told you to simplify. Okay, so the directions today are to simplify. Oh man, Johan. Okay, let me give you a quick story before we start simplifying radicals. If you want to write these down, you can. This is how you know that a radical is completely simplified. The radicand would have no perfect squares left. The radicand would not have fractions. We're going to talk about that tomorrow. And there are no radicals in the denominator if you're dealing with a fraction. Both of those last two ones we will zoom in on tomorrow, not today. You have a simplify function in your calculator? Yeah, I'm probably gonna not on the quiz. All right. So before we start simplifying these, I'm gonna give a little story just because it's fun. If this helps you, great. If it doesn't, then you can ignore it. Okay. Once upon a time in a town called Numberland, the prime numbers developed an evil scheme to take over the world. So, do we know our prime numbers, by the way? We know what it means to be prime, right? Prime numbers are numbers for which the only factors are itself and 1. 2 is prime, 3 is prime, 5 is prime, 7 is prime. Don't get prime mixed up with even and odd, okay? Just because it's an odd number doesn't mean it's prime. And for 2, just because it's an even number doesn't mean it's not prime. What's the next prime number after 7? 11. 13, 17. Okay, so knowing your prime numbers is definitely really helpful. Okay. So the authorities took action and decided to throw all the prime numbers in jail. The jails were shaped like radicals. But the prime numbers were too smart for the authorities. They found that if they could locate an identical prime twin, then together they could escape the jail. Yay, we're free, yippee! So they had to find a twin, and that was the only way they could escape jail. Them and their partner got out of jail. Their twin. But those who could not find a twin were stuck in jail forever. Aw, shucks. That poor 5, stuck in jail. Can't ever get out of that square root. Okay, so here's how it works. You take the number, and you think of 2 things that multiply to get that number. There are multiple ways to do this. For this one, I went with 25 and 3. Okay? 25 is 5 times 5. So, if you look at all the prime numbers, we've got 5, 5, and 3. So, the 5 escapes jail, and the 3 is stuck in jail forever. So the square root of 75 is 5 root 3. That is the simplified version of the square root of 75. They both equal the same thing, but this one is more simple. Okay? So we already did that, the square root of 75. Okay? Remember that you can do these different ways. So if you chose different factors for that, let's say you chose 5 and 15, you're still going to end up with the same answer. 5 times 15. When you get to a prime number, when you're factor treeing and you get to a prime number, I want you to circle it. So this one's prime. Now I'm going to keep going with this one. It's 5 times 3, prime, prime. Then you look for pairs. Oh, I see a pair. The pair escapes. Oh, and then the one all by itself is left in jail. Okay, let's do this next one, 45. I think of 5 times 9 first. You might think of something else. That's fine. 5 is prime. 9 is not. So we keep going, and this one's going to be the opposite of the one we just did. A 3 escapes, and a 5 is left over. Okay, 200. Let's do 20 times 10, because I'm going to show you something else in a minute that I don't want to use 102. Okay, neither of those are prime, so don't circle them. 10 is 5 times 2, circle, circle, prime, prime. 20, I'll go with 5 times 4, prime, circle. And then 4 is 2 times 2. Multiple numbers are going to escape jail this time, so let me tell you what happens when multiple numbers escape. I see a pair, so I'm going to cross it out, and I'm going to write it in the real world, outside of jail. Oh, I see another pair. So I'm going to cross it off, and I'm going to put it outside in the real world. And then I see one stuck. No partner, no twin. So he is stuck in jail. If multiple numbers escape, or if multiple numbers are stuck in jail, you multiply them together. Multiply them back together, because that's what we were doing. Those are all multiples, and so we're going to multiply them. So the final answer to this one is 10 root 2. Now, for number 2 and number 3, well, for all of these, I want to show you one more way if you don't like the factor tree way. And I think you actually might like this way because y'all have really good number sense, okay? So, like on this one, the square root of 45, if you know your perfect squares really well, what you can do is just go, oh, that's divisible by a perfect square. It's 9 times 5. And then, oh, the square root of 9 is 3. It's a perfect square. And then you're already at your answer, and you didn't factor tree anything at all. See that? You can do that with the 200 as well. Sorry, square root of 200. Oh, that's a perfect square times 2. 100 times 2. Well, the square root of 100 is 10, and now I'm done solving this problem. See how it's a little less work if you really know your perfect squares. If you think that way is easier and you practice with that way and you feel confident, then that is fine. Okay? Let's try some more. Go ahead and try these. I'm going to pause it. Okay, so looking at number 4, remember you can choose any two numbers that multiply to get 18. I'll just grab 6 and 3. 3 times 2. Now, what we need to worry about is that there was already a number on the outside, so we need to make sure we don't forget that number. So, there was already a 5, then a 3 escapes, and then a 2 is left over. So the final answer to number 4 is 5 times 3, 15 root 2. How's it going, Abbas? You want me to help you on this one? 24 root 2? Okay, let's work it. What two numbers did you multiply to get 150? When something ends in a 0, I usually use 15 and 10, like 10 in that number, but that's fine. Okay, 75 and 2? Whatever float you wrote. Okay, 75 is what? 25 times 3? I'm circling numbers when I get to prime numbers. Okay, now we're done. When you reach a dead end on every branch of the tree, when you reach a dead end, that means when you reach a prime number, you stop and you circle them. No, Rishi, I just talked about that earlier. We don't put plus or minus because it doesn't say x squared equals a number. The square root of 4 is just 2. It's not plus or minus 2. Okay, anyways, so there was already a 2 there. There was already a 2 there. And then a 5 escaped. And then, oh no, there's 2 numbers without a twin. There's a 3 without a twin, and there's a 2 without a twin. They go right back in jail. They go right back in jail. So the final answer is 10 root 6. Is that okay? Thanks. The better you practice, the better you'll get. Okay. It's important to have good number sense, okay? So when you don't have a calculator with you, or you can't find the square root button on your cell phone or something, it's good to know what the square root of 10 is approximately. So the way that you can approximate a radical is to find out what perfect square it's close to. Let me give you an example. Okay, the square root of 19. What perfect squares are around that? Which one's a little bit less than the square root of 19? Good. Which one's a little bit more? Square root of 25. So the square root of 16 is 4. The square root of 25 is 5. Is 19 closer to 16 or closer to 25? It's closer to 16. So our answer is between 4 and 5, but it's a little bit closer to 4. So if we guessed, I don't know, what would you guess? 4.3 maybe? Now go to your calculator and take the square root of 19. 4.35. So 4.4 would have been a better guess, right? Okay, 24. All right, that, I'm not even going to do the other one on the other side. That is really close to the square root of 25, which is 5. So it's going to be a number really close to 5. It's going to be a little bit less than 5, but it's going to be really close to 5. This just helps you understand about what each radical equals, because we can't do square roots in our head, the decimal form of it. We can't. So it's good to kind of know what it equals. So that one was 4.89, which would have been 4.9, right? Let's do this last one. Square root of 51. That's going to be bigger than the square root of 49. A little bit bigger than 49. It's only, 3 bigger than 49. 2 bigger. Hello. And so I would say, what, 7.2, 7.3? A little bit more than 7. So the real answer is square root of 51, 7.14. 14, yeah. Okay, so that's my spiel on approximating. Let's see. We have a few here that we can work on. This is just more practice. You have a lot of this in your homework, so I'm going to skip this for just a minute. I want to talk about square rooting perfect squares before some of you have to leave, okay? Okay, square rooting perfect squares. Some of these were in your Mad Minute. What we're going to do is look at these one at a time. We're going to look at the square root of 9, we're going to look at the square root of x squared, and we're going to look at the square root of y to the 4th. Okay, the square root of 9 is 3. Check, so we're done with that. Now the square root of x squared, you're looking for pairs. So a square root and an x squared, those are going to cancel, right? Or you could think of it as a factor tree. X squared is x times x. So the square root of x squared is just x because an x escapes. And then y to the 4th, what you're really doing is you're looking for pairs of y's. How many pairs of y's do I have if it's y to the 4th? Well, I have 2 pairs of y's. So those would both escape. It'd be y squared. Notice what you're doing when you're taking the square root is you're taking the exponent and you're just dividing it by 2. What's 2 divided by 2? 1. So it's x to the 1. What's 4 divided by 2? 2. So it's y squared. Ooh, what happens? This is, by the way, they're not all perfect squares. This is not a perfect square. So what do we do when it's not divisible by 2? Cry. What I recommend is you just separate this. I like this way. I just now thought of this. This is what I would recommend. That you make it an even exponent. So what is the square root of a to the 26th? It's a to the 13th. Because there's 13 pairs. If there's 26 a's, there's 13 pairs. And then, look, This one, the square root of a is just the square root of a. So the square root of a to the 27th is a to the 13th times the square root of a. Whew! Let's try another one that's odd, because I bet that you might be a little confused by that. Let's try another one that's odd. X to the 31st. Simplify that, please. So I would rewrite this. X to the 30th times x to the 1. How many pairs are there? Divided by 2. So that's x to the 15th times square root of x. You will get into this a lot more in Algebra 2, but we wanted to give you a taste of it right here. Okay, a few more things. So we know that squaring and square rooting are inverse operations, right? Inverse operations like addition and subtraction. So one is going to undo the other. So what's the square root of 15 squared? Well, the squared and the square root cancel, and you just get plain old 15. Do you get 15 squared? No. Do you get the square root of 15? No. The square root of 15 squared is just 15. I know it's easy, but a lot of you are actually going to, not a lot of you, a couple of you are still going to get it wrong on the quiz, but that's okay. We're going to go over it. Okay, what's the square root of 10 squared? 10. What's the square root of 1,254 squared? 1,254. Am I doing anything to these? I am simply taking the radicand and I'm doing nothing to it at all. I'm taking the radicand and I'm doing nothing to it at all. Number 3 is completely different. I need you to look at number 3 and I need you to separate those. This is saying the square root of 2 squared times the square root of 5 squared. I want you to square them each, and I want you to square them separately. What's 2 squared? 4. What's the square root of 5 squared? Oh, we went over that 10 times. It's 5. 4 times 5. So the final answer to number 3 is 20. The reason why that one's different is because there was a coefficient. There was a 2 in front of the square root 5, so it made that a totally different problem. Hope you're okay with that. 4 times 5 is 20. Okay, we have a little bit more. Bear with me. What is 2x plus 3x? Well, those are like terms, so we can add them, and it is 5x. What's 4x plus 3y? Oh, no. It's just 4x plus 3y, because they're not like terms. The same exact thing. Ooh, it's not 7xy. No, because this is addition, not multiplication, okay? So it's going to work the same exact way with radicals. If the radicals are like terms, you can add them. If they're not like terms, you keep them separate, like oil and water. They can't combine, okay? So let's look at this one right here. I already said everything that's up here. I already said that. Okay. 2 root 3 plus 5 root 3. It's like you have 2 root 3's in this hand and you have 5 of them in this hand. What's 2 plus 5? 7. So you have 7 root 3's. You have 7 of them. 7 root 3. Look at this one. 4 root 5 plus 3 root 7. Oh no. I cannot combine those because they are not like terms. And so you just leave them like that. You can't simplify them. Okay? Okay, now, the thing is that sometimes I will give you radicals that are not fully simplified. If you have to go ahead and go. You can watch the rest online. So we're going to have to do some work to this one before we can add these together. So this is not 2 root 75. This is 2. Let's see, a 5 escapes and a 3 is left over. So this is 10 root 3. So this is really saying 5 root 3 plus, we simplified it, oops, plus 10 root 3. I have 5 root 3's, I have 10 root 3's, and total I have 15 root 3's. So sometimes you will need to simplify one of them before you can decide if they are addable or not addable. Able to be added or not able to be added. Okay, let's work on this one. He needs some work. 4 times 2, 2 times 2. Okay, so a 2 is going to escape. There was already a 5 there. A 2 escapes, and we've got a 2 left over. Minus, we got to work on this. This one's a perfect square. 9 times 2. 9 is just 3 times 3. Okay, so there was already a 3. A 3 escapes, and a 2 is left over. And that one you can't do anything to. So let's see, I've got a square root 2 and a square root 2. So those I can combine. That's like saying 10 root 2 minus 9 root 2 plus root 3. So 10 minus 9, that's just 1. So it's just root 2 plus root 3. Whew! Lots of fun. That's all we have. We are going to spend 2 more days on this. So if this was not all clicking today, if I went too fast and didn't thoroughly explain each type of problem you could encounter, then don't worry, we will practice it. Okay?